Hello and welcome to video lesson topic 8.3 and 8.4. I will go ahead and tell you that this is a very difficult one, and I'm going to place on Google Classroom a couple more videos. One of Miss Montgomery teaching the same topic because she does a very good job on it, and then I'll try to place a video on there of just some of the basics. So let's get started. We'll do our best here, and like always, if you have questions, just comment them on the video, or you can send me a message on Remind, or you can reply to the assignment on Google Classroom. So topic 8.3 and 8.4 are tangent, sine, and cosine. And our objective is, I am learning to use tangent, and we're going to abbreviate TAN, still pronounced tangent, sine, abbreviate SIN, still pronounced sine, and cosine, abbreviated COS, ratios to determine side lengths and angles in right triangles. And we're actually going to start, if you have this in front of you, it'll be the back. I left a big space for practice. We're going to start there because something we need to understand is how this sine, cosine, and tangent works. So this only works for right triangles, and we're basically going to be solving for a missing side length, either one of the legs or the hypotenuse. Now the weird thing is it depends on which angle you pick. I call it the reference angle. You can put whatever variable you want there. I think Miss Montgomery uses the variable theta, which is a Greek symbol. So if I pick, say, this angle, you need to label your sides opposite, adjacent, and hypotenuse in reference to the angle that we picked. So here, the hypotenuse is always going to be the angle, or the side that the arrow is pointing at from the right angle. So on both of these, I can make the hypotenuse that longest side. Now, if X is our reference angle, the side opposite to X would be here. And then the side adjacent to X would be the side next to X. And I'm going to let X or Y or whatever variable you want to use be the other angle here. The side across from that reference angle is going to be the opposite, and then the side next to your reference angle is going to be the adjacent. And then you have three. You got tangent, sine, and cosine, and these are ratios. So if we wanted the tangent of X, it's going to be whatever the side length is over the opposite being on top, and then adjacent in the bottom. Sine would be the opposite over the hypotenuse, and then cosine would be the adjacent over the hypotenuse. And I know you're like, I don't have any idea what that means. Like, what? I don't understand. Well, I got a little abbreviation, a little mnemonic device to help you remember how to set up these ratios. TOA. This is trigonometry. Okay, it's just a branch of mathematics that is involved in geometry. And S stands for sine, O stands for opposite, H stands for hypotenuse. C stands for cosine, A stands for adjacent, H stands for hypotenuse. T stands for tangent, O stands for opposite, A stands for adjacent. And basically all this is just a little rhyme to help us remember how to set up our fractions. So you may want to keep this handy as you're working through, because we're going to use it over and over and over. So tangent is opposite over adjacent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And then we got this thing called identity that we'll come back to. So for example 1, it says write the tangent, sine, and cosine ratios for angle T and angle U. So if T is our reference angle, let's let it be X, then we need to write the ratio of the opposite side of T over the adjacent side of T. Now I'm going to do this in pencil because I'll have to erase it when we switch the angles. So if T is the reference angle, then the side that's the hypotenuse is going to be 5. The side opposite to T is going to be 3, and the side adjacent to T or next to T is going to be 4. So if we wanted the tangent, remember SO, CA, TOA, the tangent is going to be the side opposite over the adjacent. So the tangent of angle T is going to be 3 over 4. Opposite over adjacent. The sine of angle T is going to be the opposite side over the hypotenuse. Opposite here would be 3. Hypotenuse is going to be 5. And then the tangent, or excuse me, the cosine of angle T is going to be the adjacent side over the hypotenuse, A over H. So it would be 4 over 5. And basically what's going to happen is whenever you switch to U, let's say that this is our new reference angle, U. I'm going to let it be Y here as my variable, however many degrees. It's just going to flip what's opposite and adjacent, because now your adjacent side is going to be next to U. Your opposite side is going to be across from U. So 4 is going to be opposite, 3 is going to be adjacent. So when we fill this out, the tangent of angle U, tangent is TOA, O stands for opposite, A is adjacent. Opposite would be 4, and adjacent would be 3. Notice it flipped the tangent ratio. And then next is going to be sine. So sine of angle U is going to be the opposite over the hypotenuse. So 4 over 5. And then cosine of angle U is going to be the adjacent side over the hypotenuse, which would be 3 over 5. 3 being the adjacent, 5 being the hypotenuse. So this is basically the framework to allow you to set up ratios for tangent, sine, and cosine. Example 2, you just repeat this process. I would label my sides hypotenuse, and then you're never going to use the right angle to take the sine, cosine, and tan of. You can only use the other two angles. So we're going to do sine of T, cosine of T, sine of G, cosine of G. So the sides, let's start with T, opposite and adjacent. The side opposite to T is 8. The side adjacent to T is 15. 17 still being the hypotenuse. So if we wanted the sine, remember SO, CA, TOA, the sine of T would be the opposite side over the hypotenuse. Opposite being 8, and then the hypotenuse being 17. The cosine would be the adjacent side over the hypotenuse. Adjacent being 15, hypotenuse being 17. And then whenever I change the angle, that's my reference angle, it's going to flip my opposite and adjacent sides. So if G is now my reference angle, the side opposite to it is going to be 15, the side adjacent to it is going to be 8. So the sine would be 15 over 17, and the cosine, which is adjacent over hypotenuse, is going to be 8 over 17. You're like, well, why is this important? Well, the thing that you can do with it is now solve for a side that you don't know, which is what we're going to do in example 4. And then example 3. Example 4, we're going to solve for a missing angle that we don't know. So for example 3, we got our reference angle is 54 degrees. Remember, we're not going to use the right angle, which means my hypotenuse is going to be this longest side. The side opposite to 54 is going to be W, the missing side, and then the side next to 54 is going to be 10. So if we're using this SOHCAHTOA, the two sides we're working with are the opposite and the adjacent. Tangent is opposite and adjacent, so that's what we're going to use. We're going to take the tan of 54 degrees, which honestly is just a number. In fact, what I can do is type that in my calculator and show you. And if we look at my calculator, right now it's in radian. We're working with 54 degrees, so I have to change this calculator into degree mode. And the way I do that is I hit mode. And then whatever calculator you're working with, you'll have to have it in degree mode. So now I'm in degree mode on here. And then I can exit back out and type in tan of 54, which is just a number. So I want you to keep that in mind as we're working here. Tan of 54 is just a number. So once we have that, we can set up our ratio. And tan is opposite over adjacent, so W over, I believe that was 10. Yep. Here would be my advice to you. This is kind of hard to do, but if we were to put tan of 54 over 1, because you can put anything over 1 and make it a fraction. Now you can cross multiply. So cross multiply and you'll get W is equal to 10 times the tan of 54, or tangent of 54, and that can just be plugged into a calculator. Your iPhone will let you do tan, sine, and cosine as well. And then I think Android, you can actually download the app for one of these TI calculators. So if I take my iPhone and I turn it sideways, you can see it has sine, cosine, and tan on here. So if you or somebody that lives in your house has an iPhone, you can still work with this. It's tan of 54, and then 54, and then type in tan, and then you'll multiply that times 10, 13.76. We're going to round to the nearest tenth, but you can do the same thing on the calculator. 10 times the tan of 54, you'll still get approximately 8. I'm actually going to change the W where it's located on part B, because I don't want to use tan every time, and that one's tan as well. So if I make a new problem here out of part B, 28 degrees is our reference angle, and then we got 1.0, we got now this side that's blank, and we got the hypotenuse is W. The opposite side of 28 would be the 1.0. W is the hypotenuse, and then this side is again blank. It's our adjacent side. For sine, cosine, and tan, the sides that we have right now are opposite and hypotenuse. We don't know what adjacent is. So opposite and hypotenuse would be sine, O and H. So we're going to use sine of the angle is equal to 1.0 over W. Now once you have that, I would again put sine of 28 over 1 and cross multiply, and I'll get W times the sine of 28 is equal to 1 times 1.0, which is 1.0. And then you have W times this number, sine of 28, that's just a number. So what we're going to do, the opposite of multiplying by sine of 28 is going to be divide by sine of 28. So we get W is equal to, and in my calculator, I can type in 1 divided by, and then sine of 28, and that's going to give me 2.1. Typically we round to the nearest tenth unless the directions tell us otherwise. I'm going to skip part C because you're just going to repeat the process. Let me see if I can find the answer though for you. Answer is 3.8. So if you wanted to work that out on your own, answer is 3.8. Alright, lastly we have example 4. And example 4 is solve for the missing angle. Now in my opinion this is the easier part because it takes a lot less time. So if we wanted to find the measure of angle X, we're going to label our sides. So here's hypotenuse. And then the side opposite to X is 6. The side adjacent to X is 8. We have all three sides given, so we can use sine, cosine, or tan. It doesn't really matter. So let's say I wanted to use cosine. Cosine of your angle, which in this case is angle X, is equal to A over H. 8 over 10, your adjacent over your hypotenuse. Now, this is kind of odd. The opposite of cosine is called cosine inverse. And the way you write that is you take cosine and raise it to the -1. And what you're doing is that on both sides. Cosine inverse would cancel out this cosine. Cosine inverse of 8 over 10 would give you your answer. Now on the TI calculators, like mine, it's pretty easy. You just hit second and then cosine. Because if you look on here, it says cosine to the -1. By the way, you can also type this in on any computer online and just do it on Google. And then I type 8 over 10 and I get 36.8 degrees, or 36.9 degrees if I round it to the nearest tenth. Angle X equals 36.9 degrees. Repeat this process for angle Y here, except we're not using cosine on this one, and I'll show you why. So here's angle Y. The hypotenuse is going to be the longest side, and then if we label, the opposite side would be 100, the adjacent side would be 41. Now we don't have the hypotenuse, so anything sine, cosine, or tan that uses hypotenuse, we're not really going to be able to use. So we can't use sine, we can't use cosine, they both use hypotenuse. We're going to have to use whichever one has opposite and adjacent, which is tangent. So tan, or tangent of angle Y, is equal to the opposite side over the hypotenuse, 100 over 41. And anytime we're solving for an angle measure, we're going to use cosine inverse, sine inverse, or tan inverse. In this case, we're going to use tan inverse. Tan inverse of 100 over 41. And then you type that into the calculator. Now, I don't think that you can do the inverses on your iPhone because it simply doesn't have them. So unfortunately, you can only use sine, cosine, and tan, but there's no second button to do to the -1. So those won't work. You'll have to have either a calculator like this or a calculator online. But we would hit second, tan, and then 100 over 41. It looks like I get 67.7 degrees. So angle Y has a measure of 67.7 degrees. Okay, last thing is identity, which I believe comes from section 8-4. Your identity would be any equation or any value between X is between 0 and 90 degrees that satisfies this equation. Sine of X is equal to the cosine of 90 minus X. If you guys got any questions, make sure to let me know. Again, I will post Miss Montgomery's video as long as I can get that on there from Google Classroom, and any other resources that I can find.